In this video, we're going to take a look at some more systems of differential equations, but we're going to find particular solutions. I wanted to do this first example. It piggybacks off of another video I have, in which we have, in both of these, we have a third variable t, right, which we don't explicitly write. But in this first example in particular, the derivative of that function x of t is equivalent to 10 y of t, right? And then likewise, if we took the derivative of the function y of t, it is negative 10x. So they're related to each other in that term. Their rates are related to the original function of the other variable, right? The other function. So what we can do here is let's just start by taking the derivative of both sides with respect to t, right? That way I can get y prime in terms of x and substitute in the other equation. So for equation 1, x double prime equals 10 y prime. So therefore y prime is 1/10, or x double prime over 10. And now I can substitute, right, the y prime for y prime. So I'm going to plug in that x double prime over 10. X double prime over 10 equals negative 10x, right? I used equation 2 here. All right. Let's go and multiply by 10, get rid of that fraction. And set an equal to 0, we can use our characteristic equation, right? X double prime plus 100x equals 0. So therefore, the characteristic equation, r squared plus 100 equals 0, so r is plus or minus 10i. Okay, we were solving for our function x, so therefore x of t, with I, right, we'll go in and use the trig notation, trig form. C1 cosine 10t plus C2, which C2 is complex, that's right, sine 10t. Okay, that's the most common notation. Now, y prime is negative 10x, right? So I'm sorry, y, let's use that one. I don't want y prime yet. I want to know what y is. So it's x prime divided by 10. So therefore I need x prime. Okay, derivative of cosine 10t, that is what, negative 10 c1 sine 10t. And derivative of sine 10t is 10 cosine, so plus c2, plus 10 c2 cosine 10t. Okay, but y prime, oh sorry, why do I keep doing that? Y is x prime over 10. Okay, so dividing that by 10, we would just have negative c1 sine 10t and plus c2 cosine 10t. All right, there's our general solution. We have both x and y, but now we need to use these initial conditions. X of 0 equals 3 and y of 0 equals 4. Let's do a new color here. Blue sounds good. All right, so x of 0 is 3 yields the fact that 3 equals C1 times cosine 10 times 0, right? C1, cosine of 0 is 1, so we'll just do C1, I'm using this one here, plus C2 sine 10t. Well, when we plug in t is 0, right, sine of 0 is 0, so that one's done. We get C1 equals 3. And y of 0 equals 4. Okay, that will yield 4. Again, when we plug in t is 0, get negative C1 times 0. So C2 times cosine 0 is just C2. Easy systems here. So we have our C1 and C2, so let's plug them in, and we end with x of t equals C1, 3 cosine 10t, plus C2, 4 sine 10t. Y of t is negative C1, so negative 3 sine 10t, and plus 4 cosine 10t. And if you want ordered consistent, right, we could swap those, but that doesn't matter. Okay, that is the particular solution for that first one. Let's move on to the second one here. Okay, how do we want to do this? Looking at it, I don't really see a way to use elimination, right, to try to combine them to eliminate a variable effectively, because then we'd still have x prime and y prime. So going off of the technique of substitution method, and once we solve for y, we can do its derivative. Let's do that. So looking at equation 1, we can solve for y and state that y equals 3x minus x prime. Okay. Now if I substitute that here, I have all x's on the right-hand side, but we want x's throughout, right? I only want one function here. So let's go ahead and do y prime. Again, this all with respect to that third variable t, right? 3x prime minus x double prime. Now we're going to take both of those and substitute them into equation 2. So on the left, we will have equation 2, 3x prime minus x double prime. On the right, we have 5x minus 3 times y primes, or y, minus 3y, right? So we're using this here, but multiply by negative 3. So minus 9x and then plus 3x prime. Okay, now we have an equation all in terms of x of t. Let's go ahead and add that x double prime on the right. Right, we'll get the left-hand side equal to 0. So x double prime. Subtract 3x prime, and those actually cancel. So 5x minus 9x is negative 4x. Oops. Okay. Again, a characteristic equation. R squared minus 4 equals 0. R is plus or minus 2. So in terms of t, our function x is c1 e to the negative 2t plus c2 e to the 2t. All right, for y, remember above here, we need x and x prime. So let's go ahead and do x prime. Negative 2 c1 e negative 2t plus 2c2 e to the 2t. I'm going to go and change colors here, so therefore y of t, then we have both x and y here, 3x, so 3 times c1 e negative 2t plus 3c2 e 2t, minus x prime, so that becomes plus 2c1 e negative 2t minus 2c2 e 2t. Okay, there was 3x minus x prime, right? Combining like terms, we now have 5c1 e negative 2t, and then plus c2 e to the 2t. Alrighty, almost done. Again, we're doing particular solution, right? So find the C1 and C2 using our initial conditions. So x of 0 equals 1. X of 0 equals 1. Oops. X of 0 equals 1. That means that 1, plug in 0 for t, we'd have C1 plus C2. Right, e to the 0 is just 1. And then using y of 0 equals negative 1, that will give us 5c1 plus c2. Now we have a system of equations with c1 and c2, a system within a system, right? We had a system of differential equations, now we have a system of linear, c1 and c2. All right, let's get a new color in here. So I would say just subtract, right? Multiply this second one by negative. So we're going to just subtract these two. 1 minus 1 is 2. C1 minus 5c1 is negative 4c1, and then the c2's cancel. So c1 equals negative 1/2. All right, the first one looks easiest to substitute. So if c1 is negative 1/2, we'd have 1 equals negative 1/2 plus c2. Add the 1/2, c2 then is 3/2. And about done. That means then that our solution, x of t, is c1 e negative 2t, so negative 1/2 e negative 2t, plus c2 plus 3/2 e 2t. Y of t, we have 5c1, so negative 5/2 e to the negative 2t, plus c2, so plus 3/2 e to the 2t. Okay, that's the particular solution to that system of differential equations given the initial conditions.